Hello all. I wanted to record some of these examples from the homework that's not collected because there were a few of the ways that the calculations were presented that were different than the ways I'm used to seeing them. And some of the written examples I found a little bit confusing. So I figured I'd record this and maybe it will help you with your understanding. Maybe not. So if it's helpful, great. If not, go ahead and ignore it. So the first one that I'm recording is number 4, the replace or not replace an asset. So in this case, you're purchasing a machine for $25,000, or in the past you purchased a machine for $25,000. You've been using it for a while. It has a remaining book value of $14,000. Currently has a market value of 0. So this machine is a sunk value. You're ignoring the fact that you have the machine. When you operate this machine, it costs you $1.50 in variable costs per part produced. So the machine is going to be producing 20,000 units per year, and that is going to be relevant. In order for this machine to function for another 3 years, you need to invest $1,000 in it. So that is going to be relevant. Alternatively, you could purchase a new machine, and if you purchase a new machine, you're going to have to spend $6,000. And if that new machine is purchased, it will make 20,000 parts per year, and that will cost you 90 cents per part to make those 20,000 parts. So the question is, should you keep the existing machine or should you buy the new machine? So the way I was taught to set this up is that you create a keep column and you create a replace column. So if you keep the machine, you need to spend $1,000 to do the overhaul. And then when that machine is used, you're going to create 20,000 parts at $1.50 a part. So you will have expenses of $90,000 in the year, each year. And the cost is going to be $91,000 a year to operate that machine. In the case where you replace the machine, you're going to spend $6,000 to replace the machine, and it's going to produce 20,000 parts, and the parts will cost you 90 cents per part at a cost of $54,000. So the total cost of replacing the machine is $60,000. So when you compare those two, you take the 91,000, which is obviously more, and the case of replacing it, which cost you $60,000, and the difference would be $31,000 saved if you replace the machine. So the answer would be you'd have $31,000 saved by replacing the machine. So that's what I was taught how to do it. Now the example that he shows you, he just does this last column. And technically, okay, that's correct. So they're saying that if you replace the machine, you have an outflow of $6,000. You would save spending the $1,000 for the overhaul, and you would have $36,000 savings a year in operating costs. So the savings would be $31,000. The way I do it, you don't even have to mess with doing this because, I mean, you could do that across, but you just have to compare these two numbers and it comes up with the $31,000. And from my perspective, that was easier to understand. Either way works, gets you the same number. Okay, number 5, we want to decide if we're going to close a division or we're going to keep a division operating. So he uses the avoidable costs, and that's fine. I always just have a hard time dealing with that. So again, here's the revenues, and we have our variable costs, which bring us to our contribution margin. So the contribution margin is the important concept here. I fixed this multiple times and it keeps wanting to move over there. So the $20,000 should be lined up here. So we have salaries, and if we close it, these salaries will go away. And we have utilities, and if we close this division, the utilities go away. Now, the depreciation, even though it says if we close this division, the equipment's going to be thrown away, that depreciation expense doesn't go away immediately because this is a sunk cost. And so there's going to continue to be a cost because when the equipment is discarded, there's going to be some kind of a loss that's recognized. Because if the equipment is not fully depreciated, at the time they discard it, they have to recognize a loss for the amount of the book value. So they can't call that that cost is still going to exist. So there's going to either be depreciation expense or there's going to be a loss larger than the amount of depreciation expense. So this depreciation doesn't just go away. There's going to be a loss for a larger amount, or that will remain as a fixed expense that's going to continue on until they decide to dispose of it. So there's going to be that amount or some larger amount. So the way that he's dealing with it is he's saying avoidable. So he's going to record the contribution margin as a negative, and the costs that are avoidable, the costs that would go away if this were to be gotten rid of, are the salaries and the utilities. So if you take the negative, oh, I got to sneeze, hold on. So if you take the negative contribution margin, and then so we're basically flipping what we did here, was taking the contribution margin and then subtract the expenses. So we're doing a negative contribution margin and adding the expenses we won't have. So the salaries would go away, the utilities would go away. So we would have a negative 5,000. So rather than having a loss of 15,000, we only would have a let's see, I always figure out how to do this. We would only have a $5,000 loss. So what you can say is that the net income is going to decrease by 5,000. That's what they'll say. The net income decreases by $5,000. So if they close the division, the net income decreases by $5,000 because these would be the costs that are avoided when they close the division. So the way that I learned how to do it, maybe it's a little more work, I'm not sure. But if they keep it, it looks exactly the same as it was above. But if they close it, the contribution margin goes away, the salaries go away, the depreciation stays. So the operating loss becomes negative 20,000. So if you go from negative 15 to negative 20, the change is a negative 5,000. So there's a decrease in net income of $5,000. So the division should not be closed, because if you close the division, the earnings are going to go down by $5,000. So the division should continue to operate because it is contributing to the fixed cost in the amount of $5,000. So you want to continue to operate this division. All right, number 6, make or buy or lease. So the company is manufacturing the part for $25 per unit. We can buy the part for $22 per unit. $21 of it is a variable cost, so the $4 is a fixed cost. That fixed cost, because it's going to continue Whether or not you're manufacturing it means it's sunk, and so it's not relevant to the decision. Since it's not relevant to the decision, it's not part of the decision making. So we're comparing a variable cost of 21 to the buy cost of 22. So the decision is that you should continue to make it. Because that depreciation expense, even if we buy this cost externally, we're still paying that $4 of fixed cost. So if we buy them externally, it's going to be costing us the 22 that we're paying plus the $4 of fixed cost, because we may not be using that for anything else. Now, if the problem were to tell us that that part of the factory would be used to manufacture some more profitable product, then it would become possibly more beneficial to us to buy the product at $22, because that $4 of fixed cost would be generating a more profitable product. Number 7, take or reject a special order. So productive capacity, first thing you want to look at is if you have the productive capacity for this. So we can produce 30,000 units. We're currently selling 23,000 units, so we have capacity of 7,000. They're offering to buy 2,000. So we can take this order. We have capacity to produce this order. So, okay, we could do this. So they want to buy 2,000 units at $20. So the revenue from this is 40. Our variable costs are 21. So 2,000 units times $21, it costs us more to produce these than we would be selling them for. So there's no way we want to do this. We want to reject this. Process or not process. So the way we want to assess this is we want to determine the sales price that we get, or the change in sales price from the point of split off to when it's processed further. So the sales price of product X increases by $10 if we process it further, and the sales price of product Z increases by $30 if we do further processing. The cost of further processing is $15 for product X, and the further processing costs are $20 for product Z. So product X, we get $10 more revenue, but it costs us $15 of additional costs. So we wouldn't want to do this because it's putting more money in and we're getting less revenue for it. So there's no sense in continuing this processing. We might as well just sell it once it gets split off and not spend any more time on it. For product Z, we're going to increase the value of it. We're going to get $30 more in revenue for spending $20 more. So the profits will increase by $10 for continuing with this product. So this one we would continue the processing and sell it at a later point in time. And number 9, last but not least, this is a case where you have constraints. So we do not have enough processing, either capability, or we have a shortage of materials. And so we have to have full demand so we can sell either of these products. So as much as we can manufacture of these products, we would be able to sell. So what we're looking for is the one that gives us the highest profitability. So the way you want to do this is calculate your contribution margin for each of the products. So product X gives us a contribution margin of $40 per unit, and Z gives us a contribution margin of $70 per product. And then we're going to divide that by the pounds of constraint. So it takes 2 pounds per unit for product X, and 4 pounds to create a unit of product Z. So when we look at the contribution margin by pound of constraint, 1 pound of the constrained product, so 1 pound of the raw material that we have a shortage of results in $20 of contribution margin if we use it for product X. And 1 pound of the constrained raw material results in $17.50 of contribution margin if we use it in product Z. So we're better off using our raw material to produce product X because it gives us more money to put towards our fixed cost than using it in product Z. So we're better off producing product X first until all the demand for that is fulfilled, and then focusing on producing product Z. So you would want to fill all your demand for X before you start filling your demand for Z, because it's going to cover your fixed cost faster than product Z will. Okay.